KURINJI Senior Secondary School, CBSE, Namakkal.
Successful result producing school in state every year.
Administered by the Board of Directors with over 35 years of experience in the teaching field.
Special attention on art, craft, music, dance, silambam, yoga, skating and karate.
Focus on Hindi Sabha and Spell Bee Olympiad exams.
Smart class for effective and innovative learning and well-furnished library.
Solitary importance on sports and games in state and national level.
WhatsApp facilities to know activities of students and school inside the campus.
Free bus for LKG to 8th standard.
Free, hygienic and nutritious food.
NEET, JEE, IIT coaching experts from Rajasthan and Andhra Pradesh along with our effective teachers.
Admission registration for classes LKG to +2.
KURINJI Education Institution, Kavetipatti, Namakkal. Admission in progress. CBSE, KG to 12, contact 9025895176. Metric 6 to 12, contact 9344567484. For online admission, log on to www.kurinjischoolnkl.in.
In continuation to the last class, okay, based on previous classes from this chapter ray optics, what the concept we discussed and what the derivations we had. Now we are going to discuss some example problems, right? Okay. So example problem 1. Here, see here, suppose that the lower half of the concave mirror's reflecting surface, right? So what is the concave mirror? What is the reflecting surface? We know. Suppose for example, you can see here, it is the concave mirror. For example, this picture is not belongs to this example problem, but you just see here, it is the concave mirror, it is the reflecting surface, it is the reflecting surface, okay. Suppose that the lower half of the concave mirror's reflecting surface, so it is lower half, just imagine, right, not this same picture, but you just imagine, covered with an opaque material, like what is that, optically opaque, so which does not allow light, full stop. What effect will this have on the image of an object placed in front of the mirror? What effect will this have on the image of an object placed in front of the mirror? I will repeat once again. Suppose that the lower half of the concave mirror's reflecting surface, suppose that the lower half of the concave mirror's reflecting surface covered with an opaque material, full stop. What effect will this have? What effect will this have on the image of an object? On the image of an object placed in front of the mirror. Okay. So you just imagine the concave mirror. So the lower half is covered with opaque material. In front of the concave mirror, they arranged or they kept an object. So what about the image of the object? What about the image of the object? After reading this question, you have to get answer on your own, right? So generally, what is the answer? Now we are going to see. So the answer is actually, we are thinking that the image will not form, or the image also will be half of the size of the object. So what is that? There are two halves, no? So suppose for example, if it is an extended object, first half and second half, like that we can separate. So we may think that when we cover the lower part of the concave mirror with opaque material, the last half will not appear in place of image. That is our imagination, generally. But it is wrong. It is wrong. So the answer will be, the image will be formed, the total image, the complete image of an object will be formed. But the intensity will be decreased. So whatever the intensity which is regarding the object, out of that we will get less intensity, low intensity. That is the answer. Okay, right. See this. Now I will go through the solution. You may think that the image will now show only half of the object, but taking the laws of reflection to be true for all the points of the remaining part of the mirror, the image will be that of the whole object. So he is saying that because laws of reflection it has to satisfy, no? So the angle of incidence is equal to angle of reflection, and incident ray, normal, reflected ray lie in the same plane, To satisfy these two, so the image will belongs to the whole object, but as the area of the reflecting surface has been reduced, the intensity of the image will be low. Okay, right. Next, so example 2. See here, a mobile phone lies along the principal axis of a concave mirror as shown in the figure. Full stop. Show by suitable diagram the formation of its image. Show by suitable diagram the formation of its image. So this is the object, So this image, this picture you have to see, this ray diagram you have to observe. So it is the mobile phone, right? So olden days mobile phone, there is some antenna like material, right? So this is the object, it is the image. You can see this image, right? So this part will be here and this part will be here, right? Explain why the magnification is not uniform. Will the distortion of image depend on the location of the phone with respect to the mirror? So there are two things. One is why the magnification is not uniform. That is the question 1. Second question is, will the distortion of image depend on the location of the phone with respect to the mirror? Right? So two questions are here. First one is, a mobile phone lies along the principal axis of a concave mirror as shown in the figure, right? Show by suitable diagram the formation of its image, right? And next, explain why the magnification is not uniform. Will the distortion of image depend on the location of the phone with respect to the mirror? Right. So now we are going to see the solution. See here, the ray diagram for the formation of image of the phone, as shown in the figure, right? See this. So it is the object, it is the image, right? So rest of the things you know. So here we are taking 3 incident rays, 1, right? Next it is right, it is 2 and it is 3. Okay, it is 2, it is 3. So 1, 2, 3 are the 3 incident rays, and reflected rays 1, next 2, and next 3. So 3 reflected rays, right? So these all are going to meet here, right? So this is because of image which is formed because of meeting 3 reflected rays, right? And if you observe the image, generally you can see that this size, so whatever the size which is here, that is same as here, but whatever it is here, that is like distorted. So this image will be, you can say that distorted image, okay? It is, this side is same as this side, but this side is like enlarged, right? So that is the situation, how the image is formed, distorted image, okay, right? See this, the ray diagram for the formation of the image of the plane of the phone, mobile phone, sorry this is not a plane, it is phone, as shown in the figure. The image of the part which is on the plane perpendicular to principal axis will be on the same plane, it will be of the same size, that is B dash C is equal to BC. So this is same size, that's I already told you, this is same size. We can imagine why the image is distorted. So he told that we can imagine why the image is distorted. So why the image is distorted, So whatever the 2 light rays which are coming here, this is what one light ray and this is what another light ray, right? This is what one light ray and this is what another light ray. How it will be, see here. One light ray is here, another one is here. So what is going to happen? One light ray is here, another one is here. So because of these two, so because of the situation from reflected rays of light, so this part of the mobile we are seeing like this. That is what here it is A, here it is A dash, and it is the principal axis. It is the principal axis. Okay, right. So it is BC. It is BC, and it is like you can say that it is like B dash C. B dash C. Okay, C is the point here. Suppose if you assume this is also same like C, then it is the length, like one of the dimension of the mobile phone. It is BC, and it is like B dash C. B dash C is equal to BC. Here is no problem, but here only this is what this length, this dimension is going to increased. So that is the reason the image is not same like object. Okay, we are not worrying about the size, because if the size is increased means it may be magnified image, but here it is not the magnified image, it is the distorted image. So please try to understand the difference between magnified image and distorted image. Okay, right. Next, example 3. See here. So in case of example 3, an object is placed at 1 10 centimeter, 2 5 centimeter in front of a concave mirror of radius of curvature 15 centimeter, of radius of curvature 15 centimeter, full stop. Find the position, nature and magnification of the image. Find the position, nature and magnification of the image in each case. I will repeat once again. An object is placed at 10 centimeter, 5 centimeters in front of a concave mirror of radius of curvature 15 centimeters. So when I am reading these two lines of information, you have to imagine what is concave mirror, what is the front of the concave mirror and what is the back of the concave mirror, what is the reflected surface, what is the rough surface, okay, and what is meant by radius of curvature, what is the object distance. This and all I have to imagine. Right. Next, find the position, nature and magnification of the image in each case. In each case. Each case means in case of 1 and in case of 2. Right. Right. Now we are going to solve this problem. See here. In our previous classes we got the derivation. Radius of curvature is equal to 2 into focal length. So from that we can say F is equal to R by 2. R is equal to 2F means F is equal to R by 2. No. So focal length F is equal to R by 2. That is equal to minus 15 centimeters. Minus 15 centimeters by 2. That is equal to minus 7.5 centimeters. Minus 7.5 centimeters. Okay. Right. Next. Here 1. So it is 1 more. When the object is at 10 centimeters from concave mirror, that is what object distance U is equal to minus 10 centimeters. Object distance U is equal to minus 10 centimeter. So this relation, that is what mirror equation or mirror formula. 1 by F is equal to 1 by U plus 1 by V. Otherwise 1 by V plus 1 by U is equal to 1 by F. Right. So U is equal to minus 10 and F is equal to minus 7.5. F is equal to minus 7.5. So here V is equal to minus 30. V is equal to minus 30. See here, by solving this mathematically, we will get it as V is equal to minus 30. So as per sign convention, so U is in minus and these are the given things. F is minus and U is also in minus, then we are getting V as minus. So V as minus means we can expect the position of the image. You can imagine, you can expect the position of the image. So where is the position of the image? It is the same side of the object, because U is minus, no. So V is also minus. So these two, image and object, are the same size of the mirror. Okay, right. Now magnification M is equal to minus V by U. Magnification M is equal to minus V by U. So minus V is minus 30, U is minus 10. So it will get cancelled, then finally the answer will be minus 3. The answer will be minus 3. Okay, right. Image is magnified, real and inverted. Image is magnified, real and inverted. Okay, so here second one, u is equal to minus 5, u is equal to minus, it is the second case. First case we found the magnification and we found position and nature of image also. So what is the magnification? Minus 3. So it means that the image is, the size of the image is 3 times to the size of the object. So that magnification formula also in our previous classes we discussed, that is m is equal to h, height of the image by height of the object, that is equal to minus v by u. That formula only we are using here once again. So anyhow here the position of the image is same side of the object and nature is, what is that, real and okay, nature is real and you can also say that magnified. Based on this you can say that magnified, real and inverted okay, right. Next second case. So here u is equal to minus 5, u is equal to minus 5, then 1 by v plus 1 by u is equal to 1 by f, right. Come on, v is equal to 15 centimeters. So if you solve this mathematically, if you do this addition, right, then you will get it as v is equal to 15 centimeters. So if you observe carefully, u is minus 5 but v is plus. So when it is plus, then what about it? It is along positive x-axis, right? So it is other side of the mirror, other side of the object. The position of the image is other side of the object, okay, right. And moreover you can say that image is behind the mirror, it is virtual, right. So concave mirror has one side reflecting surface, another side rough surface, so that it is other side of the mirror means, behind the mirror means, okay, other side of the mirror or behind the mirror means it will be because of, okay, virtual, it is because of the what is that, rays, reflected rays, light rays extending back. So it is virtual image, and as usual magnification m is equal, the formula is minus v by u, okay, right. It is minus v by u. When it is minus v by u, minus v is 15, right, and minus u is, right, m is equal to minus v by u, that is minus v is 15 and then u is equal to minus 5, right. So then it will be 15 by minus of minus 5, that is plus. So 15 by 5 means it is 3, okay, that is magnified, virtual and erect, right. So here only we decided virtual, and because of this magnification you can say that magnified and erect, right. So it is, I already told you, upward is positive and downward is negative, right. Upward is positive and downward is negative regarding the image or object according to Cartesian sign convention, okay, right. So this is all about example 3. Now we are going to discuss example 4, right. First I will read the question, then I will go for solution. See here, suppose while sitting in a parked car, you notice a jogger, right, who is juggling, a jogger approaching towards you in the side view mirror or rear view mirror of radius of curvature 2 meters, full stop. If the jogger is running at a speed of 5 meters per second, how fast the image of the jogger appear to move, the image of the jogger appear to move when the jogger is A 39 meters, B 29 meters, C 19 meters and D 9 meters away from you, right. You just imagine you are sitting in a parked car, the car is in stationary position, right. The speed of the car, the velocity of the car is 0. You notice a jogger from your rear view mirror, just beside the driver there is a rear view mirror, no, it is a convex mirror, right? So the radius of curvature of the mirror is 2 meters, right? So a jogger is running towards the mirror, he is approaching the mirror, right? Running at a speed of 5 meters per second, it is a constant speed. How fast the image of the jogger appear to move when the jogger is at 39 meters from the mirror, 29 meters from the mirror, 19 meters from the mirror and 9 meters from the mirror. Okay, so these are all different positions of a jogger. So at these positions you have to find right the speed of the image. You have to find speed of the image, how fast the image of the jogger appear to move when the jogger is at different positions, right? See the solution. So this is the formula for image distance. V is equal to fu by u minus f. Actually it is 1 by f is equal to 1 by v plus 1 by u. That only we are writing like this. There is no difference, right? Convex mirror r is equal to 2 meters, then automatically you know f is equal to 1 meters. Now for first situation, right? So for first position of the jogger it is 39 meters, right? So when it is 39 meters, u is equal to minus 39. U is equal to minus 39. U is equal to minus 39, right? So when u is equal to minus 39 and f is equal to 1, f is equal to 1 meter, then what about v? So as usual, mathematically it will be 39 by 40. So numerator also minus is there, denominator also minus is there. So it will be 39 by 40 meters, right? It is the image distance. It is the image distance. Okay, right? After 1 second, position of image is after 1 second, because he is approaching the mirror with a constant speed of 5 meters per second. See here, 5 meters per second is the constant speed, and this is the u value. Initially it is minus 39, but in 1 second what happened? He traveled and he covered 5 meters distance, no, because the speed is 5 meters per second. So when he covered 5 meters per second, what about that u? See here, minus 39 plus 4. So after 1 second he is at 34 meters. He is at 34 meters. So if you take u as minus 34, then it will be the position of the jogger's image. It will be the position of the jogger's image after 1 second, right? Now we are going to find shift in the position of the image. Shift in the position of the image in 1 second. It will be, you just have to subtract from here to there, right? 39 by 40 minus 34 by 35. So mathematically you can get it as 1 by 280 meters. 1 by 280 meters. This is the shift in the position of the image in 1 second. Next, this is what average speed of image when the jogger is in between 39 meters and 34 meters from the mirror is 1 by 280 meters per second. Average speed of the image when jogger is in between 39 meters and 34 meters from the mirror is 1 by 280 meters per second. 1 by 280 meters per second. So it is the average speed. Okay, in 1 second this is the shift in the image, no? So in that same second 1 by 280 meters per second is the average speed. Similarly, but this problem is not only for 39 meters, no? So we have to calculate for 29, 19 and 9 also. So follow the same process. By following the same process, for u is equal to minus 29 meters, comma minus 19 meters and minus 9 meters, the speed of the image appears to move. The speed of the image, the image appears to move. The image appears to move is 1 by 150 meters per second here. So how we got 1 by 280 here in case of minus 39 meters? Similarly, for minus 29 meters it is 1 by 150 meters per second, and minus 19 meters it is 1 by 60 meters per second, and minus 9 meters 1 by 10 meters per second respectively, right? So at last, for a person sitting in a car, speed of the jogger image appears to increase. So see all these values, 1 by 280, 1 by 150, 1 by 60, 1 by 10. So based on these things, you can conclude that the speed of the jogger's image appears to increase. Okay, that is. So in this class, we discussed 4 example problems, right? So in our physics, not only discussion about the concepts. After discussion about the concepts, derivations came, right? So after completion of derivations, we have to go through the example problems also. So go through this video again and again, and you observe each and every example problem clearly. Okay, then you will get it as more knowledge practically, right? You will get it as more knowledge practically. Okay, ma? Thank you.